Okay, I hope now all of you can see the screen, right?
Yes, ma'am.
Okay. So first of all, I congratulate you all for completing your first year of graduation, and now you are SYBSc students, right? So congratulations and welcome to your second year of your graduation. So with that, uh, as you know, we have kept the career counseling sessions. So I would like to share my knowledge or give some tips on the topic embedded systems and IoT. So you have the subject IoT at your SYBSc level. So before starting with that subject, I would like to briefly introduce it, and I can share with you some uh, job opportunities, or if you want to career in this particular field, in this particular area, embedded systems and IoT, then what skill sets you require, so that I would like to share with you. So anyone interested in the IoT or embedded, so you will get the overall idea what is embedded system, what is IoT, what all things are included under this topic. So you can choose this field as if you are interested. Clear? So the purpose of keeping this session is that to briefly introduce the various areas under the computer science, and to inform you about the various career opportunities and various courses that you can do, or what are the skill sets required, so what all things you should do very properly if you want to proceed with a particular field. Because at now you are at the SY level, so now you have throughout the first year you have got the idea about what all subjects are there and what is computer science, what is programming. So basic knowledge you have now. So now we can briefly introduce you about the various areas. Clear? So that is what is the main purpose of this. So today we are going to uh, have an idea about the embedded systems and IoT. So before moving to an embedded system, what is embedded system, what is IoT, I would like to tell you the differentiation between the electronic devices, embedded devices, and IoT. What is the difference between that? Just a minute. I think TY students are also joining. We'll just wait for some time. I think TY students are also. So we will wait for 2 minutes. We'll just wait for 1 more minute and then we'll continue. Okay, I think now many of our TY students, all new TY students, also have joined. So let me continue. So let me start once again. So I would like to congratulate two new TY students also who have been progressed from SY to TY. So congratulations to TY, all TY students. As this is your last year, all the very best for your TY. And see, at the starting of the year, we have kept the induction sessions for you people, just to give you an overall idea about the various computer science fields in which you can do the career. So what are the basic knowledge required for that, what are the basic skill sets required if you want to do the career in particular area, in particular subject, or as per your liking, if you want to proceed further, then what courses you can do so that you can improve on your skill sets. Clear? Even what are the career opportunities, what are the different industries that provide the job in this particular area. So all these things we are going to discuss in this particular induction sessions. So today I am here to guide you or share my knowledge with you people regarding embedded systems and IoT. Now we are having SY and upcoming SY and TY, both classes are here. So TY student who have uh, now in TY, they have already done the IoT, so they must be having idea about IoT. But who have joining now in SY, they don't have any idea about what is IoT. So let me briefly introduce you first about what is IoT, what is embedded system. So I would like to start with, or I would like to start by briefly introducing you the difference between the electronic devices, embedded devices, and IoT devices. So let us start first with the electronic devices. Let us start first with the electronic devices. Now see, electronic devices works only with your electricity. Like it requires only the power consumption voltage. Clear? So that is all, that is what is your electronic devices. So like you can have a fan or mixer or old lifts. Nowadays we are having controlled lifts. So I'm not talking about that lift, but if you observe these devices, if you observe the fan, if you observe the mixer, it simply works on electricity. Clear? It simply works on electricity. So that is about your electronic devices. Next is the embedded devices. Now see, the embedded systems are the computer hardware. When we mean to say computer hardware, it means it contains the microprocessor or microcontroller. Clear? And the softwares or the programs that are embedded into the everyday things, like that are embedded into your microcontroller. So now you can have a difference when you are talking about the electronic devices. Now let us take an example, fan. So do you have any program which the fan is executing? Simply you are switching on the button, fan is getting the power supply and it starts running. Fine. Now what is embedded then? Embedded system or embedded device have have the hardware consisting of a microcontroller or a microprocessor, into which we are going to load a program, or we can say software. Let it be a very small program, doesn't matter, even if you have a 4 lines of a code, but that device will work on that particular instructions. Clear? So when you can say the device is embedded, when you are having a hardware and software both, then you can say that that particular device is embedded device. Like an example, consumer electronics, if you are talking about consumer electronics, if you are talking about, it's a cell phone, digital camera. So if you are having a digital camera is not simply your electronic device, it's an embedded device, because it has a program loaded inside the that hardware on which your camera works. So there are programs which are required to capture the image, to make the different processings on the image, like you can zoom, you can crop the image, then likewise you can do the various operations on the image. So how those operations are performed? Those operations are performed on the basis of the instructions. So instructions nothing but the program which you have written. Then calculator is again an example of embedded system. So this is one group, that is the consumer electronics. Another group is home appliances. So microwave, oven, washing machine, lightning machine. What is lightning machine? Which you do the lightning at your windows at the time of Diwali or festivals time. When you do the lightning, you are getting the different patterns of the lights. Clear? For 1 or 2 seconds it will keep on continuously blinking, then it may change the speed. So how those patterns are getting generated? On the basis of the program, because you have loaded the program such a way that, so lightning it is changing the pattern after the specific interval of time. So that lightning machine which you are lightning doing the lightning at your window at the time of your festivals, that is also an embedded, because it has a program loaded inside that. Then you are having a office automation, which includes fax machines, copier in the sense Xerox machines, printers, scanners. So these are all your office automation machines that are also embedded, because it has the hardware and software, both the things. Next group is the business equipment. Business equipment contains, as an example, alarm system, card reader, or biometric or card reader. You can understand when you used to come to the college, now we are having a digital attendance, right? So in every lecture you used to get that machine provided to you by the peon, and then you used to touch your iCard so that your attendance gets marked. So why you are touching that iCard? So in that iCard, RFID is embedded into that card, and that machine is reading the data from RFID. Clear? Next is the biometrics, which you can see at the ground floor besides the lift, which is for faculties or which is for the staff. So whenever we are coming to the college, what we have to do is we have to give our fingerprints to that biometrics, which will compare the biometric, and then our staff attendance is captured through the biometric. So any particular staff member, what time that person had come, entered into the college, and at what time, at the time of leaving also we have to give it. So that machine is what it is doing, it is capturing the fingerprint, and then already our fingerprints have been already registered in that. Whenever any new member is joining to the college, the registration of the biometrics is done. So employee ID, name, and the fingerprint is saved in the database. And then whenever every day when that staff member is giving the fingerprint, what that machine is doing, that machine is capturing the fingerprint, and it is uh, comparing the fingerprint which are saved in the database. So like my name is Vaidehi. So whenever I will give my fingerprints, it will search or it will compare in the database for the fingerprints at, and in some row it will find that, the fingerprint is matched. So obviously it will search for the employee ID. So and so is the employee ID, so and so is the name is the Vaidehi. So attendance is marked for that day for the Vaidehi. Is it clear? So how it is done? Because you are having a machine, so you are having some hardware components which are capturing the fingerprint, then database, then comparison, how the comparison is done in the database by using the program. So again, it is an embedded. Why? Because it has the hardware and software both. So you just see any of the example from any of the group. The most important thing is that when you are having hardware and software both, then only you can say that the particular device is an embedded device. So that is the difference between electronic device and embedded device. Electronic devices have only the physical component and it works only on the electricity. But embedded devices has embedded devices has hardware components also, and the program or the software embedded inside that hardware, and those devices are running with the coordination of that hardware and software both. It needs the program. Embedded devices needs the program also. That means what? It needs the instruction, then only it can work. Only with the hardware it cannot work. Clear? So that is the clear cut distinction between electronic devices and embedded devices. Then I would like to give you some basic characteristics of embedded system. So embedded system consumes low power. It consumes the low power to run the microcontroller. So whatever the devices we have listed, like your attendance, you can consider your attendance machine or biometric machine, or you can consider calculator, fax machine. It does not take much power. It does not consume much power. Fine. Then next is what? single function, many of the time these devices are single functioned. Single functioned in the sense what? They are prepared, or they have been manufactured to uh, perform only one task. So if you see the example, digital camera, what it does, it just captures the image, it captures the image, and it do the image related task only. It does not wash your clothes. Washing machine does not take a picture or does not take an image. Clear? Lightning machine, it can perform only the lightning part. Fine. Biometric machine, biometric device, it can perform only the biometric. Card reader, like you can assume your device, like TY people must be knowing the, you are having that device where you need where you used to keep your iCard, where to which you used to touch your iCard. So that device is what? The device is single function. Clear? It is only prepared, only manufactured for attendance purpose only. Clear? So it cannot perform multiple tasks. So many of the time, majority of the time, embedded devices have been manufactured for performing a designated task, allocated task only, one single specific task only. But now there are certain exceptions for that. As an example, mobile, laptops, desktops, tablets. These are the exceptions. Why? Because these are also an embedded devices. Why? Because you when you are talking about a mobile, when you are talking about a laptop, desktop, what is this? This is an hardware. You are having a microcontroller inside that, and also you are loading the operating systems, many software. So of course these are the embedded devices. But yes, these are not designed for performing a single function. Your mobile phones and your laptops, desktops can perform many different tasks. So these are some of the exceptions. But majority of the time, 90-95% of the time, you can say that the embedded systems are, or embedded devices are manufactured or designed to
प्ले बटन आ गया है। अब सिल्वर प्ले बटन आने में इतनी खुशी नहीं। इस
please
सारी
you
फील्डिंग
mute
के बाद
yourself.
पूरा मेहनत लगन लगा दी इस गेम को आने में। बेसिकली ये एक अर्ली एक्सेस।
So Um, these are some of the exceptions which perform the multiple tasks. You can browse, you can listen to the music on your mobiles, on your laptops. You can have a Zoom meetings. You can, like on laptop, you can play a games, or you can have a Word or Excel. Certain kind of tasks you can do. You can do the browsing, downloading, uploading. You can do, or you can have a SQL, you can install Oracle and you can execute your DBMS part, or you can do so many things. You can do so many things with your laptop. Same with the case. Same is the case. Now you are having a smartphone. So mobile phones again you are using for so many things. So these are some of the exceptions for this particular characteristics. But apart from that, if you say, then it is a single function. Maybe real time, your embedded systems may work with the real time data. So biometric machine is working with the real time data, so it remains the idle, and when someone comes and place the finger, that time it becomes active. So it is working on the real time data. Fine. They are small in size, low cost, uh, uh, it does not cost much, and it is a small size. So maybe portable, like your mobile is portable, even that your attendance machine is portable. So many of the time, majority of the time, these devices are small size and low cost. Performance is good, error free, and since it is error free, you can rely on that. So whatever data is being captured by that embedded devices, you can rely on that. Why? Because it is error free and it gives you the good performance. So these are some of the characteristics of embedded system. So that is what is basically we have discussed what is the difference between embedded and electronic devices. So till now, anybody has any doubt till this part? Anybody wants to ask anything? Okay. So now we can proceed further to see then what is IoT. Now we are clear with the electronic devices and embedded devices. Now we can move on to the IoT. Then what is the difference between embedded devices and IoT devices? Now see IoT devices, these are the things, internet of things. So the name itself is internet. So obviously this devices, now what I told you, what the embedded include hardware and software. So in IoT devices, there is a hardware, there is a software, added thing is the networking. Clear? So IoT is the next step of the embedded. IoT is the next step of embedded. So here, in case of embedded, maybe your data is so IoT, as the name itself tells you, IoT. What is the full form? Internet of Things. Clear? Now, so what is the added part of IoT is the networking part. The added part is the networking part. To So there is an hardware, there is an software, and along with that, you are having a networking. Okay. Now, Internet of Things. So, what do you mean by things? Whatever the IO devices, whatever the input output devices you are having, that is being called as things. So whenever you are dealing with the embedded, you may be accepting the data from various sources like a like a sensors, or from the mobile, here, or from the car. So you can capture the data from any of this. So these are called as things, which you are connecting it to the internet, and so the name is Internet of Things. In the sense, what the sensors, the mobiles, your laptops, your desktop applications have been connected together with the internet, and so it is called as Internet of Things. So obviously it includes the hardware, software, and networking capabilities that are embedded into everyday things. So nowadays, whatever the things you are using, mostly we are saying a smartphone, smart cities. So when we are saying smart, what does we mean to say? We mean to say from anywhere, anywhere. So what we want is we want to be a connected. Clear? So when we mean to say smart mobiles, smart cities, smart things. So what is smart is when we are putting the things together and connected from anywhere, when you can access these things. Things means what? Mobile. It may be your data. You are keeping your data on email, and then you can access your data from anywhere. So when you can say that you can access the data, you can connect to a particular device, particular data. So this particular device, particular data is called as the thing. So when you can connect to the particular thing from anywhere, any way, clear? So that is called as how you can do this, how you can do the connection by networking only, clear? And that's why the name is Internet of Things. So now you are clear that networking is the added part to networking is the added part to embedded, clear? Now example of such uh, devices are RFID smart guns, Wi-Fi typewriters. So see, Wi-Fi is there, it is there. So it's a Wi-Fi typewriter is a IoT device. Smart smoke detectors, then air quality sensor, soil monitoring. Now, what is this soil monitoring is? As an example, I can explain you soil monitoring as one of the IoT device. See, what you can have is you, therefore, farmers in the field. All of you, please check that you are on the mute. Fine. So soil monitoring is what we can do is we can place the IoT device or the components or the sensors in the field, and that components can sense, like we have a humidity sensor which can sense the humidity of the soil, clear? So that humidity sensor or along with the other components we can place it in the field, and we can continuously monitor on the humidity, and whatever is the humidity sensed, that is measured by the that sensor, that can be put it on the cloud, clear? So that can be put it on the cloud, and by sitting at a home or by sitting at anywhere, you should be able to monitor the humidity of the soil. So this is the half part. Now if you found that the humidity is less, we need to water the soil, we need to water the soil, so we can improve it further. We can give the command from sitting anywhere that the water motor should start. So that can be a whole device, that can be a whole project, and that can be called as the IoT. Why IoT and why not embedded? Because there are sensors, there are hardwares which we have kept it on the field, kept it in the field, and then these devices are working on the program. It is continuously checking the humidity of the soil, and then we can give the we can write down the program by writing the if condition. If the humidity goes beyond this level, agar itna niche aata hai, then the water motor should start, clear? So this is working on the program. So there is a hardware, sensors, and there is a program. And why it is IoT then? Because we are monitoring the humidity by sitting at some other place. We are accessing the data by sitting at some other place. So there is a networking, and so it's a IoT device. So this is what is the difference between embedded and IoT. So it includes either sending captured or sensor data. So IoT includes what? Like I told you, the sensor will sense the data. What is the humidity as an example, or you are having a smoke detector also, so which can detect the smoke, and that captured data or the sensitivity or whatever the data is being captured by the sensor, that data you can send it on the cloud, or you can do the other way also. You can read the data from the cloud, or you can receive the information from the cloud, and you can take a certain action, certain specific action that should happen at some other location, and you are sitting at other location, isn't it? So this is what is the things happen in the IoT. You are sitting at somewhere else, you are sitting at one location, and you are observing, you are taking the readings of some machines or some situation. You can, yeah, we are having a temperature sensor also, so at sitting at one location you can monitor the temperature also at particular room, isn't it? So this kind of things we can do it. We can sit at one location and we can record, or we can read, or we can monitor the data which is at some other location, and we can take a action that should occur at the other location by sitting at some remote location. So that is what is the internet of things. So the important difference between the embedded is uh it's not involving any internet. Clear? IoT is involving the internet. That is the main difference. So before entering into this field, embedded and IoT, you should have a clear cut distinction between the electronic devices, embedded devices, and IoT devices. Fine. Now let us discuss some of the basic characteristics. Uh, Connectivity, of course, when you are talking about the IoT, of course, you should have a good proper connectivity, which is very important for IoT infrastructure, so that you can be at anyone can access from anywhere you can access, and anytime you can access. So anyone, anywhere, anytime, there should be a connectivity. Clear? So that should guarantee, then only your IoT devices, you can say it's giving a good performance. So without the connection, nothing makes any sense. There is no sense if there is no connectivity for IoT devices. Second thing is intelligence and identity. So extraction of the knowledge. So whatever the data is being generated by the sensor, by biometric, or by any other way. For example, sensor generates the data, but the data will only be useful if it is interpreted properly. So whatever data is being gathered by the sensors, that should be interpreted properly. Now see, the whole cycle is important. Capturing the data is very important. After capturing, next level is intelligence and identification. That is, the data should be interpreted very properly. So each IoT device has a unique identity, and this identification is very useful, helpful in tracking the equipment at the times for querying its status. So capturing the data and interpreting that data in the proper format is very important. Clear? So that is the next step you should be able to capture. And once it has been interpreted in the proper format, then you can do the analysis of that uh, data. Clear? You can do the analysis and then you can take a certain action. So it is very clear cut steps are there. Sensors or the hardware part will generate the data, and hardware parts will generate the data. Generated data should be interpreted in the proper format, and then once the data is interpreted in the proper format, then you can have an analysis of that data. Clear? Then the next is scalability. Of course, the number of elements connected to the IoT zone is increasing day by day. So IoT setup should be capable of handling massive expansion. So there should be a scope to expand the IoT device, because when we are saying IoT means the number of things have been connected to the internet. So scalability is important because the things will keep on getting connected to the, or it will keep on increasing. The number of devices connected to the internet will keep on increasing day by day. Clear? Next is the dynamic and self adaptation. That is what, let us take an example, simple. Assume that a camera meant for a surveillance. So you know the CCTV cameras which are there for the surveillance, keep on watching. So it should be adaptable to work in the different conditions, like different light situations. That camera should work in the morning, in the afternoon, in the night. So because of the darkness, that camera is not able to capture the things, so it's of no use. So whatever the devices you are using, that should be the dynamic. Dynamic in the sense what, they should react to the real time situation. Whatever may be the real time situation, they should be able to react. And that's why we can call it as a dynamic and self adapting. Self adapting in the sense what, they themselves should understand how to react to a particular situation. So simple example to understand this is the camera. It should work in any time. It should work in days also. It should work at night also. Then only there is a sense in putting the camera for surveillances. Fine. So that is the dynamic and self adaptation. Then next is the safety. Since we are dealing with the various hardware components, there can be several voltage levels. There might be some connections. So it is, there is a danger of sensitive personal details also. So safety in two terms, when we are dealing with the hardware, then hardware safety is important. We should take a proper precaution that voltage should not exceed, so that because if the voltage is increased or much more, then your hardware components may get exploited. Clear? So that is one kind of safety, and another kind of safety is the data safety. Whatever the data is being sensed, that should be, like, it depends on the application, but if you are capturing any personal data, then that should be kept very secured. It should not get leaked to anyone. So safety in two terms, one is data safety and another one is hardware safety. And the third one is internet safety also. Because if someone else tries to hack your net, then your data will be hacked. Clear? So internet safety is also important. So hardware safety, data safety, and internet safety, these are all the challenges when you are working on any IoT device. So you should take care of all these things. So security part is also very important. Security in various terms. Clear? Security in various terms. You need to implement the algorithms for security of data, security of internet also. Clear? So how the IoT works, the whole thing which I have told you is being shown with one picture. On the very left side, you can say the sensors. So there are different kinds of sensors. Temperature sensor, which will give you the what is the current temperature of the room, of the environment, current environment, whatever. Humidity sensor gives you the humidity of the soil. Pressure sensor, it will give you the pressure. Motion sensor, lux sensor. So these are the kind of sensors which will capture the data. Then the next is that data will
Ma'am,
go
what is
to
the
the
lux
IoT.
sensor? Ma'am,
Hello,
ma'am, what is a lux sensor?
lux sensor. I'll come to that later. I'll just tell you. Fine.
Oh, okay, ma'am.
So first, try to understand the cycle, how it works. So these are the kind of sensors. So basically, in the first step, what we are doing it, we are getting the data. We are getting the data, and then that data is being sent to the IoT device which you have designed. So IoT gateway or framework, that data will go to IoT framework. From the IoT framework, the data will go to the cloud via wireless communication. So IoT, your device, which the device you have been sent, You will need to program it so that it can send your data to the cloud server through the wireless communication, and then that server, from the server you can access that data on your mobile app, so there are different applications. One application I can say you, uh, buy application, by application is there. So uh, that application can be used to access the cloud server. So there are different applications which you can use to access the data. Now if you see the arrows, these arrows are bidirectional, in the sense what I have told you, only the one way, like sensor will sense the data, send to the IoT device, then IoT device will send it to the cloud, and then the cloud, from the cloud you can access through the mobile. Okay, so that is the one. Same thing can be done in the reverse way. Now you have observed the data, you have captured the data by using some application at your mobile. Now suppose you are sensing, say suppose you are accessing the temperature sensor, and if you found that the temperature is very low or temperature is very high, okay, you are capturing the data of particular remote room, the room which is at the remote location, and you are accessing, you are capturing the data of that temperature of that room, and you have found that on your mobile application the room temperature is very high, and say suppose you have stored the things which should be placed in the cool location, so you need to take a certain action, like you should switch on the AC of that room, isn't it? So by by monitoring the data on your mobile, now you can go in the reverse, you can send the request, or you can send the instruction, that instruction through the cloud, it will go back to the IoT device, and IoT device that is, it will send the instruction back to the sensors, or it will take some action. IoT devices will have the programs inside that, so through the program the instruction will be given to the next device. जैसे ये सिर्फ sensors है, so apart from sensors you can have the devices over there, like input output devices. So assume that there is an AC connected to your IoT device. So you can send the instruction which will switch on your AC. So now this is a reverse cycle, and that's why those arrows are bidirectional. That's why those arrows are bidirectional. So this is how your IoT works. So this is the structure of the IoT, or this is the working flow of the IoT. Fine. Uh, just a minute. So now the question was asked by, what is lux sensor? So lux is the motion sensor or the light sensor. It can sense the light or motion, and that is called as the lux sensor. Is it fine? Is it fine
Yes,
to
ma'am.
you? Okay. So that is your lux and lux sensor, which can sense either
Yes,
light or,
yes, yes, ma'am. I can understand.
okay. Uh, so till now, what we have discussed is, uh, here I have completed with what is the electronic devices, what are the embedded devices, and what are the IoT devices, what are their basic characteristics, and what is the relation between these three devices, or what is the difference between these three devices, and how the basic working of IoT. So just tell me, anybody has any doubt till this point? Anything? Have you all got the basic idea ki what is uh, embedded, what is IoT, and what are the simple electronic devices. I hope all of you must have got the idea, isn't it? Now, IoT and the embedded, again, it's a huge area of computer science. So, I cannot teach you right now. It's a entire subject. In SY, you have an IoT. SY people will do it. TY people have already done it. And if you go for the MSc, then in our syllabus, in RJ syllabus, we have an advanced embedded systems. So these are the entire field, a very huge field, a very demanding field nowadays. Okay? So I have just given you ki what this area contains or what this area does basically. Clear? So now I would like to share you uh, the this was the basic idea about the embedded and IoT. Now what we can next, we cannot move on to the studying that part, uh, because it is a huge subject, as I told you. If you found interest, now you have got the basic idea. तो तुम लोगों को इसमें क्या पढ़ना पड़ेगा कि हार्डवेयर, you need to study the hardware, you need to study about the sensors, you need to study about the microcontrollers, how the microcontroller works. Then networking part is also involved in that. Programming, if you are talking about majorly C programming, that is the embedded C, and Python majorly is used in this embedded and IoT. C programming, that is the embedded C programming, and Python programming is majorly used in this. And so this is what is the requirement, I can say. Now, ongoing courses, I can tell you, if you found interest in this particular area of computer science, I have just gone through ki which are the upcoming courses for that. So this is what is a link. Uh, this course, first link which you can see. I think you can see the screen. Yes.
Yes, ma'am.
So this link gives you the course which is already being done by Professor Indranil Sen Gupta, who is the professor at Computer Science and Engineering IIT Kharagpur, and Kamalika Datta madam. So this is the course designed by these two professionals. So which course is already uploaded. So if you want to study in depth about this, so videos you will find at this particular link. You can click on this link, and preferred, like at the starting phase, now you don't know anything, so you want to start from the scratch. So you can go through the week 1, all the lectures, week 2 all the lectures, week 3 only lecture number 15, 16, 17 you can go through, week 4, week 5, week 6, and week 7 ka 36 and 37 lecture. These lectures you can go through to get the knowledge or the insights about this embedded and IoT. Week 7, lecture number 36 and 37 is the example, like the lecture number 36 is the home automation. Home automation in the sense what we are having a various appliances at our home, tube lights, fans, TV, AC, whatever the appliances we are having, those have been automated or those have been controlled by say a remote or something like that. So how this or you can say that if the uh, room temperature is very cool, then your AC should get automatically switched off. So this kind of home automation can be done if you study this embedded and IoT. So the lecture week 7 is the lecture number 36 is about the home automation, which you will find interesting. that you can go through. So overall, if you want to study in depth, this uh, and explanation is very good. So this is the most which I liked. These lectures I have liked much more. Fine. So this you can go through, and obviously these are uploaded lectures, so there is no fee and no time restriction. You can go at your time. जैसे आज एक वीडियो देखा, फिर 2 दिन के बाद एक वीडियो देखा, बट नाउ दिस 15 days, लाइक 1 जुलाई तक तुम लोगों का कुछ एकेडमिक स्टार्ट नहीं हो रहा है. So I'll say that if you found interest, you should go to these lectures and you should see these lectures. It's real. These are very nice lectures. Fine. The second course, Introduction to IoT by Professor Sudeep Mishra, 12 weeks course it is, which is starting from 26th of July. So you can register for this course. Uh, I have given you the link also for joining this. So exam date is also given, and enrollment you can do it by 2nd of August. But if you want to start, just do it before 26 only, so that you can start with the course. So this again, this is a free course. I have listed all free things. Huh? I have not listed any paid ones. Then the next is this is what is a link, Udacity and Ellison. So for that we have to log in. So I have not done the login, so I have not seen the content. But yes, if you want, you can log in simply with your Gmail account and you can go through the content. But otherwise, I don't know whether what is the depth that Udacity and Allison. But this course, these at least the I have list whatever I have listed under point number one, that you can go through, because it is right from scratch. It is started from very basic, so you will better understand this. So these are the four things which you can do. So these are the preferred courses if you are interested in this particular area. Now next, what are the career opportunities in this? So you can be a data analytics, you can be a network designer and structure. You can be a part of protection, security. You can be the part of device and hardware designing. You can be a part of cell and UI development. Cell UI is interface designing, that is UI. User interface designing is the UI development. So when you are putting the things on the cloud, when you are communicating through the mobile to the cloud, so you need the UI. जैसे मैंने तुम लोगों को बोला कि एक ऐप है जो तुम लोग मोबाइल पर डाउनलोड करके क्लाउड के साथ कम्युनिकेट कर सकते हो. ठीक है, तो उसके लिए एक यूजर इंटरफेस चाहिए ना. So for designing those kind of applications, it's again a part under the IoT. So when you are talking about IoT or embedded, it is not simply just the hardware, but that includes these so many areas. You can be a part of network designer or network engineer. Networking engineering is also required for this. Clear? So you can be a part of data analytics. Why data analytics is under the IoT is listed, I'll tell you. Because uh, huge amount of data is being generated by the sensors, or every day the new data is being generated by your sensor and hardware. Clear? And we need to analyze the data. We need to, first of all, we need to put it into the proper format, and then once it is being put it into the proper format, then we have to analyze that data. So it is, you, in short, you can say a big data analysis. So big data and how to analyze that big data, how to handle that big data, that can also be a part of the IoT. Do you understand? Because every day the sensors are generating the data. You will keep on storing that data, and then you want to analyze that data over the period of 1 week, over the period of 1 month, over the period of 1 year, and so on. You will keep on analyzing the data, and depending on that analysis, you will continue with the further strategies. Clear? So to plan on for the further strategies, or to improve that particular IoT device, you need to analyze the data. So that can also be the thing. So data analysis is also, big data analytics is also required under IoT. So you can do you can be the expertise in any of this, and you will get the, you can get it the career opportunities in IoT. जैसे एक नेटवर्किंग, तुम लोगों ने एक नेटवर्किंग बहुत स्ट्रांग बना लिया, still you have the opportunity in the IoT field. Is it clear? You can be in expertise in any one, any two, or any of this, whichever you like, and you can be a part of IoT. So these are all the career opportunities for embedded or IoT expertise. So you can be a domain expert. So as a domain expert, you can be a embedded developer. See, you can be a embedded developer. Embedded developer in the sense what? Core hardware. Code hardware designing is the embedded developer. You can be a big data developer, big data handler. You can be a data scientist. You can analyze on the data. UI apps or developer, you can be a part of user interface developer for the IoT devices. So these are all the domain expertise. OT specialists are networking engineering, uh, integration engineering. Integration in the sense what? The different modules will be generated by the different expertise. Networking part will be handled by the network engineer. Embedded part designing, working with the hardware will be done by the embedded developer. But this has to be put it together, this has to be integrated. So that's why you need the integration engineer, isn't it? Then UX designer, IoT, and at the end, installation engineer, that is the IoT architect, security and trust developer. So this is what is the these are all the career opportunities in the IoT. Then what are the emerging roles? If you are the part of IoT professional, some industry, then what can be your roles? आपको क्या क्या करना पड़ सकता है? You can be a robot coordinator. You can be a full stack developer. You can be an industrial engineer, industrial data scientist, product manager, solution architect. So which I have already explained to you. Developer, it can be a software developer, it can be a hardware developer, embedded developer, it can be a UI developer, it can be anything. You can be a robot coordinator. So these all can be the roles which you need to perform. So these are the roles uh, that can be performed. Now for this, what skill sets you require? That is what is I told you ki you can do expertise in any one of this field, or any two, or any three, or you can keep on improve, you can keep on developing the skills one after the other. Like if you are interested more in hardware designing, then you can be the part of hardware designing, that is the embedded systems, networking, programming, of course. Programming is important. So as I told you ki C and Python is majorly used in case of IoT. Then communication protocols, analytics, data analytics, as I told you, network security, UI designing, cloud computing, edge computing, and soft skills. So these are all the skills which you can gain knowledge about this. You can be an expertise in these things, and then you can get the career opportunities. So hardware and sensors, networking, application designing, these are all the areas in which you can get the expertise, and you can be the part of IoT. As an IoT professional, embedded designer, programming using C, programming using embedded C, programming and complex application using C, programming advanced embedded applications using C. So C and Python are very important to get into this. C and Python. These are very two important things. Then you should know about the file handling. You should know about the networking. You should know the debugging using C. Then embedded networking, embedded networking, RTOS. That RTOS is what? Real time operating system applications using C. Then developing the devices embedded using C. So these are all things which you should know as an IoT professional. Now, last but important, companies that hire the IoT professionals. So these are the companies which hire the. This is the least. Apart from the Accenture, L&T, Amazon, Bosch, SAP, Cisco. Apart from this, Delta, Valio, E-Infochips, Johnson Control, and many more companies are there which can hire the IoT professionals. There is a role of IoT professional in these companies. These companies require the IoT professionals for the multiple roles which I have listed already. So that's the end from my side. Now, do you have any queries? Then let me know. So this is all about the IoT. What is electronic? What is embedded? And what is IoT? The difference. What are the career opportunities? Then, if you want to get it into this field, then what all skill sets you required? Which is the area where you should work on if you want to get into this? And these are all the things. The brief idea I have given you about the field of embedded and IoT, which is very much emerging field because see, being an IoT expertise nowadays there is for every problem. What you should be able to do is you should be able to realize the real life problem, and you can find out the solution for that problem, like how the technology can solve this problem. So you can just have a real life problem. Simply I can tell you, तुम लोगों का attendance machine. So keeping the records on the pages, and then scrutinizing those records, then finding out the defaulters was very crucial for why it was very crucial because everything was on the piece of paper. So manually searching for defaulters was very difficult, and then even if we try to digitize it, we have to take it on the paper, and then every day we have to do the entry on the computer in the Excel sheet. Like roll number wise, we have to keep on marking as present absent. So which was very time consuming job. Here now what happens is directly you are touching your iCard to that machine, and that machine is capturing the RFID data. You are capturing your roll number and directly marking it as you present or absent. So at the end, directly we are getting the list of students with the attendance, and then we can sort it on the basis of the attendance, and easily within a minute we can get a defaulter list. So which was the problem, like doing the things manually was very time consuming. So likewise what you should be able to do is you find out, you should, being an IoT or embedded expert, you should be able to find out the real life problem and think that whether you can develop a system, whether you can develop a hardware device, any machine which can do this task. That is what is the thing. And these are very emerging field. Why? Because nowadays people wants everything to be automized. So how the automation will be done? By using these devices only, isn't it? And that's why this field is very demanding. This is the reason why this field is demanding, because for every problem, as an IoT expert, we should be able to find out a solution. Automation, clear, customization, you can say. Okay? So that's why this field is very emerging field. So this is all about your embedded and IoT from my side. Now we can have still 5 more minutes and then we can end up. If you have any queries, anything, if you want to ask. Why only one person is replying? There is SY, there is TY. If you want, Tanvi, then I will share this Word file on the group. Tanvi, if you want, I will provide this file on the group. Fine. Companies I have already listed. Ganesh, I have already listed the some reputed companies which hire these professionals like L&T, Amazon, Accenture, Bosch, Johnson Control. These are all the companies which hire. How much time you require to master? See, as I told you, there are so many sub areas like networking, like hardware designing. So you start expertising on one area first. Like if you are interested in networking, then you do the networking and then come to this field. If you are interested in hardware designing, then you just work on the microcontroller, work on the designing connection part, how to do the connections and so on. So you work on that part and then you can come to this field, like. So, and it will take a time, of course, it's a huge area. So it is a consistent process. Consistently you should give daily, you should give some time to this, and then slowly you can start understanding this field. Of course, if you do the course, it will help you to understand the things faster. So that's why I'm telling you the first point of the courses. You can go through those videos. You will get an idea. Is it fine, Supriya? Is it fine, Supriya? Okay. Any other question? So by evening, I will make a PDF of this file and I will share it on the group of SY and TY both. Right? So should I end the meeting? If there are no queries, should I end the meeting? Okay. Good day to you all.